Hi. So, I'm Ben Adams. I'm CTO of Illyriad Games. We're making a massively multiplayer space combat game based on .NET. I'm also a Microsoft MVP, .NET Foundation Director, one of the, I think, the largest ASP.NET contributor outside Microsoft. And I also contribute to Core Effects and Core CLR. So I want to talk about performance today. So the question is, why is performance important? It's important for the delight of your customers. People hate waiting. Even if what you offer your customers is free, although there's probably some cost somewhere, people's time is valuable, and they see that they're spending their time on your product. And once you've got people's attention, you don't want to squander it. There's the cost associated with slow-performing equipment. On the reputation side of things, you can see Dropbox has moved from, on Mac, has moved from a very fast native client to a Chromium-based one, Electron, rather, and people are quite unhappy about that. So, I mean, to put it into context, you might be building things fast, but at work you may use, say, a timesheet application or an expenses application, and are they fast products? Do you enjoy using them? Normally, I don't know, maybe in the Netherlands they're really good and fast, but in my experience, when you have to put in your expenses, it's just a horrible experience. It's slow, and the company that's making that software, do you think about them? Do you think, oh, wow, they make a great product? The effect of the performance is, directly what you feel about the product. It's also, one thing that's good about performance is it's a directly quantifiable metric. You can actually measure it. It's not a woolly thing. And it affects all other KPIs, all other indicators. So for sales, 1 out of 5 online shoppers will abandon their cart because the transaction's too slow. 79% of customers will not use a website that's too slow ever again. And a 1-second delay is a 7% reduction in conversions. So if you're making 100,000 euros a month, a 1-second improvement is 7,000 euros a month. So it's a direct effect. It also affects your reputation. 34% of customers are less likely to purchase if the website's performance is poor. 60% say performance influences their impression of the company. And 33% have a negative outlook on a company with a poor performing website. Because it is a directly quantifiable metric, other people can measure it too. So Google will rank your website based on the performance of it. So how far you appear in, how far up you appear in search is directly affected by the performance of the website. Facebook, how far you appear up in, how you're surfaced to users in their newsfeed is also affected by the performance of your website. Mobile. People spend like a fortune on phones these days. You're spending close to the price of a low-end computer or a high-end computer even. And people expect that when they're using these phones that they perform just as well as their desktop computers. It might not be realistic, but that's what they expect. So they expect to wait no longer than 2 seconds for a web page to load. After that, 40% of users will abandon the website. 58% of all mobile customers expect it to render as fast as their desktop computers. And 60% of smartphone users think it should load in under 4 seconds, with 75% of people just abandoning it if it takes 5 seconds to load. So what does a second of performance mean? Amazon, they said that a slowdown of 1 second would cost them $1.6 billion annually. Bing said a 2-second delay meant they lost around 2% of queries, 4% around in clicks and user satisfaction. And Shopzilla said improving their site speed from 6 seconds to 1.2 seconds, I don't know why their website was so slow, increased their earnings by 12% and their page views by 25%. And Mozilla saw 60 million more downloads by increasing their page 2.2 seconds. What's a millisecond? Google estimates they'd lose 20% of their traffic for every 100 milliseconds it takes for their pages to load. Yahoo saw a 9% increase for 400 milliseconds. And Walmart and Amazon both saw a 1% increase for every 100 milliseconds that their websites were improved. So it's quite important. What are the challenges? Well, Moore's law, you used to just be able to buy a newer server or upgrade to the new server in the cloud now. But that doesn't have, the performance would always be increasing. But Moore's law no longer applies to single-threaded performance. It's more cores, it's more parallel. So how long something takes end-to-end is not improving by chips improving, unless they're parallel. Modern design is often with lots of microservices chained together. And then each microservice, each step you're going through, each container that you're talking to, it compounds the latency and the performance degradation. You used to see this if you, for instance, a developer would build a website with a local database, and they'd make 100 queries to the database for each page load, and they'd be like, wow, it's really fast. And then you put it into production where your website and your database were on different servers, and suddenly the performance would tank because you now have all this latency. And then with microservices, you may be chaining this up even further. And so that sort of compounds. So it's something to pay attention to. And with the rise of the cloud, you now have on-demand, per-second billing based on how much CPU you're using and memory usage. It means you only have to pay for exactly what you're using. But if your things are performing badly, it is a direct increase in your costs. So your language and framework choices now directly affect your bottom line costs. So what happened in ASP.NET Core 1.0 from Tech Empower, they described it as the degree of improvement was absolutely astonishing. So then we move on to .NET Core 2.0, which was the best yet. And just as a question, how many people use full framework? How many people use .NET Core? Okay. So everybody uses a bit of both, mostly. How many people are web-based, and how many? Yeah. And how many people are sort of desktop? Cool. So in .NET Core 2.0, it's even faster. The runtime was profile. The native part of the runtime was profile guided, optimized. There's a runtime store. It's even more cross-platform. You can do side-by-side installs. Has .NET Standard 2.0 and more compact CS proj. So in full framework and .NET 1.0, you had quite a horrible CS proj, well, or Project JSON, but we don't talk about that. You don't have a packages config directory. You don't have all this crap. You don't have to reference every single package. It's all much, much simpler. And then there was a huge improvement to all the APIs in .NET Core 2.0. So, I mean, from simple things like queue, enqueue, dequeue was 200% faster, lists 40% faster, concurrent queue went to becoming non-allocating with 350% performance improvement to enqueue and dequeue. Text was faster, concurrency was faster, I/O was faster. I mean, these are huge improvements. So, 500% faster. Everything is faster. Then there are changes to the JIT. Exception handling is an interesting one. So it had faster, if you were doing exception handling, it has a fast path for when exceptions aren't thrown, which it didn't have before. It also recognizes non-returning methods. And what does that mean? Well, throw is seen as free if you throw an exception. Well, not if you throw an exception, sorry. Having throw in a function is kind of free. If you catch an exception, it's not free. And actually throwing an exception is very expensive. So if you have throw in your function, it's free when it never runs, maybe. But it also is in your function. So you can miss out on optimizations from inlining, for instance. So if you had the code on the left where you're checking all your arguments, then that produces 102 bytes of IL, which goes to 367 bytes of assembly, and the JIT says, oh, I'm not inlining this in anything that's calling it. So you can trim it by sort of getting it doing smarter on your checks, but still, it goes from don't inline to unprofitable. You can cut your test down, so rather than checking if your input is less than 0 and also greater than the array length, you can cast them to an unsigned int, which a -1 will become a positive that's greater than the max value of an int. So you can do both checks with a single test, but again, still too big. But we're getting smaller. Ooh, go back. So there's this thing, non-returning methods. If you have a method that only throws, it's a void method, and the only thing it does is throw, then the JIT recognizes that as an exception and doesn't bother to inline it. So that means we've cut down the IL to 46 bytes, and it goes, all right, I can put this in whatever's calling it. And then you get all sorts of extra optimizations from inlining, and you're not bloating the code with all the throws of your exception handling. It does make it a little bit messier, but hey. One of the things that came in, I think, 2.2 was, and 3.0 also has been extended, is in RyuJIT. There's devirtualization. For years, the runtime team have told us, well, you seal a class because the JIT can recognize that maybe in the future at some point and convert all the virtual methods into direct calls, and they'll get faster. And for like 15 years, it was maybe that could happen. And finally, it does happen. So it devirtualizes, it works out their direct calls, can even inline them, and you get performance benefits there. So ASP.NET Core 2.0, that was the best yet. Looking at the TechM Power benchmarks, the stripped one was in the third position of all the frameworks and all the web servers out there. If you have a look at the lower graph, it's ASP.NET Core is at 3rd place, Nginx is at 31st, Node 89th place. So it's quite significant in its performance. But now we're moving on to .NET Core 3.0, which is the best yet. So it's got faster tasks and async. It's async local variables, if you use them, which you shouldn't, are faster. If you use lots of timers, prior to 3.0, you'd get a lot of contention around updating and changing them. That's all been fixed. SSL stream is a lot faster because everybody does websites over SSL now. So that's quite important. There's platform intrinsics, which are direct access to the CPU instructions, the vectorized advanced CPU instructions. Now, that might not be something you want to get into because you generally end up writing quite weird code and quite weird algorithms. But now they're quite heavily used by the runtime for 3.0. So all your, all the text encoding, UTF-8, finding the index of something in a string, they're all using the intrinsics now. So they're all much, much faster. There are so many performance improvements. I was going to just do my talk about 3.0, but then the performance improvements in 3.0. But then I saw this blog post by Stephen Talb. Has anybody seen this? Okay. Where he went through he summed up the performance improvements in 3.0. Oh no. What should I have open? Hang on. Sorry about this. There we go. Okay. And there are so many, so many improvements in 3.0. Whoops. I can't get it to work out right. Stephen wrote up here. It's well worth a read if you have enough time. So if I just start scrolling through this, can you see the scroll bar on the side there? This is just an enormous amount of performance improvements. So I think it would take possibly several days to go through them all. But .NET 3.0 is Core 3.0 is very, very, very fast. And this is on 2.0, which was faster than 1.0, which was faster than full framework. So, yeah. There's also a new JSON, system text JSON that you can use. So rather than you'd probably use Newtonsoft JSON. Now, in Box, there is a very fast JSON parser and a serializer, deserializer. That comes with 3.0. There's Event Pipe, which is cross-platform performance counters, so you can get that on Linux now as well as Windows. You can monitor things, so your time in the GC, generation, what the garbage collector is doing, how much you've got queued in the thread pool, contention rates, that kind of thing. The garbage collector has been improved, so you can now set limits for how much memory you want it to use rather than it just deciding to use all the memory on your machine. And you can set it in terms of a percentage or a fixed size. It's also aware of containers so that it behaves much better in containers. In 2.2, it was aware of the container limits, but it didn't take into account that your container was probably also running some operating system. and so it would go over the top, but it's now aware of that. And the new defaults use much less memory than before. So it'll happily go up to a gig in 2.2, but in 1.0 you'll probably be using maybe 100 megs for the same thing, and you won't get any loss of performance. There's Ready2Run and Tiered compilation. This is about improving the performance of your startup. So you can now, does anybody know NGen or has ever used NGen? Okay. So in .NET Framework, you could get faster startup by using something called NGen, which would precompile your IL to machine code. However, you have to do it on your target machine. So you'd install your app on the computer, and then you'd run NGen. So when you get a .NET Framework update, for instance, you'll notice it'll say .NET Optimizer running, and it'll be burning all your CPU while it recompiles everything on your box in a Windows update. With Ready2Run, you can compile it on your development or your CI pipeline for the target machine, rather than having to do it on the box. And then you can ship that precompiled. And then that works with tiered compilation. So that gives you faster startup, but it's not necessarily the best code because it's not optimized for the exact CPU you're running on. It can't make use of all the processor intrinsics because it doesn't know if you support AVX or SSE, etc. And tiered compilation then comes in, and any hot functions, it recompiles that at JIT time after about 20 or so iterations. It will send them off to recompile and produce faster code. So you get both faster startup and you still get the good runtime. The files are slightly larger, but it's a trade-off. It's an optional thing, trade-off if you want it or not. You can publish a single file now, so it's an improvement in performance in copying your compiled code, but it then extracts it. So you end up with a single executable, and then it extracts it to wherever you are on your first launch. And then you can also do assembly linking, which does tree shaking of any DLLs or dependencies you have. Any functions you don't call, it will take that out of your included DLLs and make them much smaller. And then that's quite good if you're doing sort of single file deployment. And then it's configurable, so you can mark things saying, I use reflection, I use these methods that you don't know about. So don't remove them. And then native interop. So there's improvements around managed C++, COM. The COM interop is part of and WinRT is part of WPF. And XAML, WinForms, those kind of workloads now coming to core. So you can move all your desktop apps onto core. And you can drive Excel from it through COM and all that sort of stuff. So when I say ASP.NET Core is the best yet, what do I mean? Okay, so versus 2.2 on the plain text, we've gone up 42% in throughput between the two versions, which is quite significant. But with that, the memory use, as I say, it's gone from 1.3 gigabytes down to 104 megabytes. And the latency has gone from 20 milliseconds down to 1 millisecond for how long do you get the request response. And then the cold start performance, this was before the Ready2Run, but is already, again, 42% faster. So from 600 milliseconds to 380. If you do use IIS, does anybody use IIS for .NET Core? Okay, that gives you good things like port sharing, you can do management, etc. There's now an in-process hosting model. Before you do an out-of-process, and you'd have Kestrel, so you'd have 2 web servers running. That's now in process, so I think it's about twice as fast. And then you can still do your forwarding with Nginx or IIS for out-of-process hosting, and then you can now go direct to Kestrel because it's approved to be internet-facing. In 3.0, there's improvements in .NET Core. So when you get a request from a user, from a browser, you'll have things like cookies, your authentication, your user agent string. You'll have all these headers that the browser will send for every request, and they'll always be exactly the same. And so in 3.0, it checks those headers and says, are they the same headers as the last request? If they are, I won't bother create. I'll just reuse the previous header. I won't recreate another string. So you can do 122 million requests, and you'll only allocate 1.7 megabytes for that. And it's a bit faster because of it. So I'll talk about some common performance issues you may have come across. So thread pool starvation is probably one of the most common ones, where sync and async aren't the right terms. It should really be blocking and async. And if you do sync over async or async over sync and you mix them, then you end up blocking a thread pool thread. And that's waiting for something else on the thread pool to come talk to it, and then you're just gnarling up all these threads that can't do anything while they're waiting. And eventually you hit the limit, and it injects a new one, say after 500 milliseconds, but you're never going to catch up if you're creating more blocks than you are clearing them. So don't use read, use read async. Don't use write, use write async. Don't do task result, await your task. Don't do task wait, all that sort of stuff. And that should help. If you do in production happen to everything seizes up, you're using no CPU whatsoever, you've got thread pool starvation going on, you can, in a panic, increase your minimum thread count that you allow in the thread pool, and that will sort of unblock it. But that's just delaying the problem, and you'll use more memory, and so you should really go fix the source and move it to async, and then it will just go away, and much better. But if you need to, like, emergency patch. HttpClient is another common one. Again, you should use async methods. You shouldn't wait on them. You should await them, rather. You should either dispose it when you use it, or you should use a static one, or even better, in ASP.NET, there's the HttpClient factory, which handles the lifetime of it for you. But otherwise, you're keeping the connections open to the server that you've connected to, and you'll end up with port exhaustion as you run out of IP addresses and ports. So the garbage collector. Now, the garbage collector, it may seem like it causes a lot of trouble, but it's actually your friend. It reduces errors. It's easier to develop with. You don't have to work out who owns what object and when to free it and memory leaks. It allows very fast allocation, but you pay for it later. And it's the biggest complaint that most people have is it's non-deterministic. You don't know when that slowdown is going to happen, when you're going to pay the price. And if you allocate a lot, you get pauses. So what does a GC pause look like? This is from our game, where a GC pause happened on the server while it was running. Don't know if you've seen it before. Right. I want to see if you can spot when the GC pause happens on the server. It's quite subtle, but see if you can spot it. And then although it turned out that was because we had there was a bug in the SDK, and it wasn't taking across the GC settings, so it had gone back to client GC rather than server GC, and it had all gone single-threaded and just shut everything down. But anyway. But that's a GC pause. So this is my summary of the garbage collector. It's like blaming your hangover on your liver when it's not really your liver's fault, the hangover. So what can you do about improving the garbage collector and how it responds? You don't need to worry about garbage collection if you don't allocate. So you want to allocate less. Don't box, which is converting value types, integers, floats, structs, into objects. It allocates. It's also slow going back and forth. Don't capture in lambdas. It's really easy to do. You don't notice you're doing it often, but you'll use a variable with the same name that's not defined in the lambda or passed to it, but is defined outside. And the C# compiler is very helpful, and it will go, yeah, I'll allow you to do that, but it will allocate when it does that. You can get around that with a new form of closure. Local functions, rather than lambdas, will help in a lot of cases because they do it a different way. Unless you're doing it async when it will allocate. Don't use link and IEnumerable and hot paths if you can avoid it. You might not be able to. You can pull your objects. So when you finish with them, you put them back in a pool and you reuse them for the next one. Make sure you clear them. There's array pool for large objects. Span, read-only span, which I think Adam went through earlier. And rather than task, you can use value task, which is good if you're always generally completing synchronously. If you have something where the result is normally immediately available, then you don't have to allocate a task. If it then goes async, because it has to wait for a network call or something, that will then allocate a task behind the scenes to feed into the value task. And there's also a weird special trick value task does where you can have reusable instances, which is used by the new IA sync enumerable, which again is coming in .NET Core 3.0. Ref returns are quite good. They're with C#7, so they work on any framework. But you can return the reference to whatever you found. You don't have to, it's probably a bad example. But if you're passing around structs, say you have an array of structs, you can then say, give me the reference to the fifth element of this struct, and I can use it like a variable and pass it around, return it from my function, that kind of thing. So I've got some, these are just things I like, so I thought I'd share them with you. I call them quality of life improvements. Exceptions. This is actually a 2.2 feature, but I like it so much. I think it deserves highlighting again. So I assume everybody uses async. Yeah? Do you like the exceptions they create? So let's say in So in full framework and earlier versions of core, if you throw an exception, you'll get something lovely like this. And it doesn't even really help you by telling you what function this move next is. Yep. Whereas in .NET Core 3, the same code. I've deleted the PDBs here because you would get line numbers, but it looks messier. We'll produce an exception like that. Oop. So it actually tells you what the function is rather than move next, and it tells you the parameters that function's taking, so you can easily go to it, and there's not all this weird junk in the middle. Okay. Let's get through these. So if I'd like to summarize by just going back to what I said at the start. Performance is directly quantifiable. You can measure it. You can also monitor it. And so part of the ASP.NET Core journey, why it's been improving, is that they do continuously monitor it. And they spot regressions and then try and bisect which source code created that and then fix it and then go back and do it. So I'd recommend that you, if you can, you measure your performance, you monitor your performance, and as I said at the start, it has a direct effect on sales, on your perception of your company, if you need to convince your managers that it's an important thing to do. So, thank you. Are there any questions? Apparently I'm going to throw this at you.
Hi. In your talk, you talked about not having closures or having a different style of closures.
Yeah.
Can you tell me something more about it? What is that solution?
Okay, so you can either just increase the number of parameters you're passing to that and to the closure, say to your Lambda, add another parameter and pass it through. Or do you know local functions? They're sort of C#. Yeah, so they don't suffer the same problem as closures.
Okay. Yeah, thank you.
Unless they're, the caveat is unless they're an async local function, and then you have the problem.
Yeah. Will C#'s 8 static local functions?
Yeah, so the static local functions prevent you accidentally capturing it.
Yeah.
Yeah.
Okay. Thank you.
So that you if you mark it static, you have to intentionally either pass it or be aware of that you're capturing the value.
Okay. Thank you.
Anyone else? Can you throw it to the back?
So what are the usual steps you'll take when you see a performance degradation and you want to solve it?
Profile it, because so there's that saying, premature optimization is the root of all evil, which is a massively taken out of context quote, because the full thing is arguing for why you should be optimizing things. He was also arguing that you should use go-tos, so take it with a pinch of salt. But one of the important things that he was highlighting wasn't like delay optimizing until you've shipped your product and all your customers are complaining about how slow it is. What he was saying was you should measure it and find out where it is, because this is even true for me, and I've been profiling for years and years. Where you think your bottlenecks are generally aren't where they actually are. What you think is the slow bit of your code. I mean, you can identify what actions is slow, but then what you think is causing that in your code is probably not. It's probably some other unrelated area. So you generally want to get a profiler and have a look at it that way.
Okay.
Does that help?
Well, so you profile with .trace or something, and then you see bottlenecks, and then you create a benchmark .NET benchmark and test it out, or?
Yeah, so you'd, I've got a slide on. So there are other profilers too, but yeah, .trace is a very good one. But yeah, then you'd isolate it. You can create a benchmark.net if it's a micro isolated thing. It's also good because then you can always run it if you've got regressions, and if you want to change the code in the future, you can say, here is somewhere we identified before, so you probably want to check those benchmarks in with your code as part of your tests. So you can go, here is somewhere we identified as a hotspot in our code, so we can then monitor if there are regressions in the future, or if we have future improvements we can do before and after. If you can isolate it to a micro benchmark, that's very helpful because it cuts out the noise of an entire running system, but you can't always do that.
Okay. Oh dear.
We have developed some quite simple microservices, and we were using server GC, and we were using more or less 400, 500 megabyte of RAM in 2.2. Then we had to change it to workstation GC, and then it changed like to 50, 60 megabyte. And performance-wise, it seems quite the same. So there is any guidelines or recommendations like why then should I move back to server GC, or should I do it in 3.0?
In 3.0, you should be able to use server GC, and it should all be perfect and work exactly the way you want. In 2.0, the server GC sort of operated in the mode where it felt it was the only thing running on the machine. It's sort of the defaults from, I don't know, .NET Framework 1.0, where you maybe had 2 CPUs on your box, and you generally had a box for an app, and now you have 64 CPUs, and those same settings just mean it dominates and just sucks up all the memory. So they've gone back and they've revisited all those settings, and made the server GC more active that it will go in. With workstation GC, it like continuously runs periodically, so it's always trimming and keeping it small. But then things move into older generations much faster. and you'll end up with pauses. I mean, if it's working for you, that's probably fine. But you'll find server GC, you should be able to get higher throughput. And yeah, it should work in 3.0 fine.
And also then, even though my container, for example, has less than one CPU, like for example has half CPU, because it's really a simple service, then it's okay to use the server GC, or then should I consider to use the workstation GC in 3.0?
That's more tricky. I don't know. It's because the server GC operates in parallel. It's got different priorities. It does more in the background collection. But if you've only got one CPU, I don't know. You'd have to measure and see.
Yeah. Okay.
As far as I know, the check that it would automatically switch into client GC.
Ah, okay.
There's only one CPU was broken for a long while until the core, and they fixed that in 3.0. So it will automatically see, oh, there's no use to doing server GC. I will just switch over to workstation.
Okay. So the answer is use server GC and it will automatically
will do
switch
it.
to workstation.
Okay,
for you.
nice. Thank you.
Okay.
Okay, I hope it don't kick anybody.
So I had this question about the optimization for publishing. Whoops. Let me just read that from my notes. You talked about publish ready to run is true setting in the .NET publish command.
Yeah.
And you mentioned that it also automatically optimizes hot code patches. Does that code get cached somewhere, or does it have to compute that every time that the hot patch runs at runtime?
It computes it every time that it runs at runtime. It does extra things, so there are, it's not just code for the CPU, but things like you can have read-only statics, which are constants, but they're calculated at runtime. So they become constants when it does the JIT mode, but it couldn't move that code into something on disk. So it's like, how many CPUs do you have? It couldn't then embed that in code on disk.
Yeah, so it's only for things that wouldn't make sense to make static at all, anyways.
Yeah. So it does precompile. So it's mostly let me see. In hardware intrinsics, it does do a version of it in Ready2Run, but it says is supported false, so it cuts all that out. And then you've got read-only statics. So if you have like a static initializer for your class, then it has to check has this run all the time in the AOT thing. Yeah. Whereas when the JIT comes along at tiered compilation, it can go, I know this has run, so I can just delete this entire section of code. And so there's extra optimizations which it wouldn't make sense to put on to cache.
Okay, thank you.
Okay, I think that's the end. There's a performance panel later, if you want to come to that, where you can ask more difficult questions. Thank you very much.